let me conclude the first concept under state variable in this particular class. As all of you are aware that we are discussing the concept of state variable, in which we are going to write the equations for dynamic variables in the given for the given electrical circuit. After writing those equations, we are going to represent those equations into matrix form. So this matrix form indirectly denotes the state model representation. That's it. Now in the previous class, I just went for solving the number of problems on how to obtain this matrix, that is x dot is equal to ax plus bu. X dot is equal to ax plus bu. Now in this class, we will try to go for another thing to conclude this state model concept, representation concept. And before going for that one, point to be noted that you can get this matrix in by he will be asking in two ways. One is he will be giving you the electrical circuit. He will be giving you the electrical circuit. Then you need to write the corresponding equations and then convert. Or else he will be giving you the transfer function. He will be giving the transfer function. Transfer function ఇచ్చినప్పుడు just without any procedure write those transfer function into form of equations as x1 dot is equal to x2, x2 dot is equal to x3. Like this goes on. The final matrix you write into xn dot from the given transfer function and convert these equations into matrix. You will get the resultant x dot is equal to ax. The resultant matrix is known as what? Will be in the form of x dot is equal to ax plus bu, where x is the state variable and u is the input. In the same way, the expression for output can be written as y is equal to cx plus du, where a, b, c, d are all are constant matrices. U is the input and x is the state variable. In general, all of you are aware that any electrical system, any type of system, it is having its input, and it is having its own output. In between, there are sub inputs and sub output variables. Those are I am treating here as x variables. ఆ x లో మళ్ళా డైనమిక్ వేరియబుల్స్ మాత్రమే కన్సిడర్ చేసి we will write the equations. Now the last thing to conclude this one is, so you observe this particular expression. So this problem, before going for problem, last concept నేను చెప్పినాను కదా, rather than asking you to represent the state model, he will give the answer and he will ask you the question. It means that rather than he is giving the transfer function, directly he will give the matrices like this. Matrices ఇచ్చి he will be asked you to find out what the transfer function. So ఇలా రివర్స్ అడిగినప్పుడు I am having one small derivation. Let me derive the same thing. So let me write here how to get the formula for determining the transfer function. So to derive that one, let me consider a state model equation. So all of you are aware that here state model equation x dot is equal to ax plus bu, and similarly the output matrix is equal to cx plus du. Now here we need to get the ratio of what y of s by u of s, that is the transfer function. For this state model, you need to convert it to transfer function. Now how to convert, means here he has given the equation in terms of x dot. So now hence to get in terms of y of s, so let me apply Laplace transformation for this one. So if you apply Laplace transformation, then your x dot will become x into x of s, okay, s into x of s plus, sorry, first step is I am applying what a Laplace transformation. So if I am applying Laplace transformation, then x dot will become s into x of s, which is equal to a into already x on the x of s plus b into u of s. From this expression, if you send the similar terms to the one side, then you will get s into x of s minus a into x of s. X of s is equal to, at the right side you will get only b into u of s. U of s. From this, if you take the common term s, then you will get s into, I am just as s is a scalar quantity and a is the matrix, hence I am multiplying with identity matrix. All of you are aware that multiplication of identity matrix will not change anything. So si minus a I am writing in this form, where I is the identity matrix, into x of s is equal to b into u of s. B into u of s. Or further, you can write x of s is equal to, further you can write x of s is equal to si minus a whole inverse into b into u of s. B into u. Equation 1. Equation 1. Now, here the task is you need to derive an expression for y by u. Y by u. Now I am taking the Laplace transformation for the output equation, applying Laplace transformation for output equation, then you will get y of s is equal to c into x of s plus d into u of s. Now if you observe this one, we need what? Y by u. So but at the right side you are having unknown term. This is what? X of s. Unknown term, this is x. So I can, you assume this one as equation 2. So simply you substitute two in one. Sorry, substitute one, equation 1 in 2. Then you will get y of s is equal to c into, what is x of s? Si minus a whole inverse into b into u of s plus d into u of s. Now if you simply, what is transfer function? Y of s by u of s. Rearrange that, you will get the transfer function as c into si minus a whole inverse into b plus d. Plus d is the formula for finding the transfer function from the matrices, where a, b, c and d all are what? Matrices. Where a, b, c and d all are what? Matrices. All are matrices. So this is the formula in general. In some of the cases, rather than asking the problems, maybe he will be asking you to, in this way, derive the expression to determine the transfer function using state model. Using state model means these are the two state model equations. So what we are having a generalized expression. So how I derived the formula to find the transfer function means just simply I applied Laplace transformation. Then I have written the expression for x of s. As all of you are aware that from the second equation, if you write the expression for this one, you will be getting this one. Now in this equation, you need to write y of s by u of s, and the unknown variable I have eliminated by substituting the value of x of s. Simply you will get this formula. You need to remember this formula to solve the to convert the given state model equation into transfer function. Now, so this is the formula what I derived here in the same thing, under which the first problem is he has given the expression like this. He has given the expression like this. Okay. Now once again, y x under he has given in the form of matrix form. Let me write once again here. So the given data here is. So the first problem is obtain the transfer function for the given state model. So here the given model is x1 dot x2 dot is equal to 1 1 1 1 into x1 x2 plus 1 1 into u, and also y is equal to 1 1 into x1 x2. So this is the given data. Now you need to convert into y of s by, you need to find out y of s by u of s. So from the given data I can say here as from the given, if you compare with that particular one, x dot is equal to ax plus bu, and y is equal to cx plus du. From this particular, you compare those equations, then you are going to get the matrix A as the matrix A is 1 1 1 1, and the matrix B is also a column matrix 1 1, and the matrix C is a row matrix 1 1 1 1, and the matrix D is 0 as he has given matrix. Now the formula for finding the transfer function is given by y of s is equal to m of formula C into Si minus A whole inverse into B plus D. As D is 0, only we will do this one. So how to do this one means, first of all you need to find out this Si minus A, that is your first step, and then after that multiply with B, multiply with B, multiply with B, and then after that one multiply with the C, multiply with the C value. Okay, so in these three cases, in these three steps we will solve the problem. Now here as a part of this problem, first let try to do Si minus A whole inverse. Please try to do Si minus A whole inverse. Si minus A whole inverse. So Si minus A whole inverse, if you try to do here, so here what Si minus A. So what is the identity matrix? 1 0 0 1. So multiply with S cavity, S 0 0 S minus the A matrix is 1 1 1 1. So you will get Si minus A as S minus 1 minus 1 minus 1 S minus 1. Now you need to find out what Si minus A whole inverse. So if you go, the formula is determinant of Si minus A inverse matrix divided by adjoint by determinant. So the formula is adjoint of A divided by determinant of Si minus A. So if you do that one simple mathematics, you will get what? Si minus A, S minus. So adjoint of that matrix, so adjoint of this matrix is S minus 1 1 1, and then S minus 1, and the determinant will be AB minus BC. So S minus 1 whole square minus 1. So if you send that one into the inside, you will get the matrix will changes to Si minus A whole inverse. The matrix will become S minus 1 divided by S minus 1 whole square minus 1 1 divided by S minus 1 whole square minus 1, and in the same way 1 divided by S minus 1 whole square minus 1, and S minus 1 divided by S minus 1 whole square minus 1 whole square minus 1. So that is the formula. Now finally you need to multiply with the same matrix Si minus A whole inverse into B. So B to multiply. What is B matrix? Here this is 2 by 2 order. And what about B matrix? So B matrix is a column matrix which is 2 by 1, and this matrix is what, 1 by 2. Now if you observe here, so the resultant of this 2 will becomes what, 2 by 1 and 1 by 2. So you will get a singular matrix finally for this one, 1 by 1. So if you multiply with B, if you multiply with B and C, this matrix, so B and C with matrices. So here the C matrix is a row matrix. C matrix is a row matrix. So if you do simple mathematics, let me write here. If you do simple mathematics, then you will get here first C to multiply just you multiply with C. C and 1 1 with this matrix Si minus A whole inverse. If you do that matrix, so this is 1 by 2 and this is 2 by 2. So finally you will get 1 by 2 matrix. 1 by 2 means a single row and 2 columns. So the first element will be S by S minus 1 whole square minus 1, and here the second element is S by S minus 1 whole square minus 1. Now in this case, now multiply with B matrix 1 by 1. So multiply this is 1 by 2 and this is 2 by 1. So resultant matrix will be a singular matrix, which will give you indirectly the transfer function, which is equal to all of you aware the formula is y of s by u of s is equal to, if you multiply these two, then you will get the formula for this one is s by s minus 1 whole square minus 1 plus s by s minus 1 whole square minus 1. So you can write 2s divided by s minus 1 whole square minus 1 is the answer for the given state model. So only the thing is here, from now onwards for the given question, if he has given A, B, C, D, so the formula already we derived is this formula. So one by one formula you need to add or multiply the matrices. Now in this case, first you need to subtract A matrix with Si minus A, and then find out its adjoint and also determinant to get the inverse, and then వచ్చిన matrix C తో multiply చేయండి, మళ్ళీ B తో multiply చేయండి. This will indirectly will give you the resultant thing y of s by u of s. So like this. So in this case, in the given మీ notes లో కూడా అదే ఇచ్చినాను, you just refer the notes. And now the second problem on the same thing here is, he has given this matrix 3 by 3 matrix. So here from this given data, if you subtract Si minus A, you will get this matrix. You will get this matrix. Now find out the adjoint of this one, then you will get Si minus A as this one. Si minus A as this one. Adjoint of this one is this. Next page lo raskunda. Yeah. So Si minus A, this one, you are going to get verify later on. Now multiply with the C matrix and then once again the B matrix, then you will get the transfer function. Okay. So in this way we can able to find out the transfer function. So here is the end of the first concept. Here is the end of this first concept. There is state model representation for the all different three models of problem. In general, you might ask in the examination. First model is, he will be giving you, so the first model here is, he will be giving you circuit. Second model is, he will be giving you the transfer function, and the third model is just now what we have completed. He will be giving you the state model and will ask you to find out the transfer function. So all the three cases I have solved. I have given the clear information in the notes also. Okay, here is the end of the first topic. Okay, now in the next, rather than wasting the time, let me jump to the next topic, that is the solution of state model. And also the state transition matrix. These two combinedly a single concept. These two are combinedly are a single concept, which I am going to conclude in this class. Sorry, I can't conclude in this class. I will start this second concept, and I will be concluding the same thing in the next class. After this, only one topic will be left over, that is controllability and observability, that we will be discussing to conclude this control system. So last two concepts are left over. So that is the solution of state model. That we will be discussing last but one concept. So I just now finally I came to the last but one concept, named as solution of state equation. So what is this solution of state equation means? Let me write here. What is solution of state equation means? Here you got state model x dot is equal to ax plus du. So what is the solution of state model means? Convert this equation x variable with respect to time. Write the equation. This is actually x dot, means in terms of dx by dt. Now you need to convert that dx by dt with respect to x of t, with respect to time x of t. Convert cheyalante the only the way is you just apply Laplace transformation, then you will get the x of s. Then after that apply what? Inverse Laplace transformation, then you will get x of t. So this is known as what? Solution of state model. One small simple concept. What is the solution of state model? For the given state model, apply Laplace transformation and then apply inverse Laplace transformation, then you will get x of t. This x of t is known as what? Solution of state model. Let us see here in the notes what I have given. Now here, so the solution of state model can be in two ways. First, let me consider. So I have considered here as a state model equation. Observe on the screen. I have considered the state model equation x dot is equal to ax plus bu. So from this particular state model equation, now I applied Laplace transformation. If you apply Laplace transformation, then x dot will be changes to x to x of s minus x of 0, where x of 0 is the initial condition. In the previous case, while deriving the expression, I assumed the initial condition as 0. Now here I am just assuming, I am not assuming any initial conditions, so just I am writing as usual. So applying Laplace transformation for x dot will give you s into x of s minus x of 0, and for all the rest of the things directly as usual the same thing. Now from this particular case, I am just extracting as usual the x of s formula. So then if you write the formula for x of s, then x of s will become is equal to si minus a whole inverse into right side mm terms untai x of 0 plus b into u of s, what we derived in the previous case. Now finally, to get what is the aim of solution here? So from x dot you need to get x of t. For that one, first what we have done, applied Laplace transformation, then you will get x of s. After that you need to apply what? Inverse Laplace transformation. Now for that particular equation, if you apply inverse Laplace transformation, then this equation will become equal to L inverse of si minus a whole inverse into x of 0 plus L inverse of si minus a into whole plus b of 0. So this is addition. This sum is known as what? This is known as what? Complete solution of the given state model. Which consists of the output when input is at initial condition, and the output with the presence of input u of t. It means that the complete solution is just like all of you aware from the mathematics, that the complete solution of a given equation is complementary solution plus particular integral. In the same way here also, the complete solution is equal to the output when input in the absence of input. In this part, if you observe this particular equation, here there is no input term u of t. at, and there is a term x of 0. X of 0 means at initial condition. At initial condition time t is equal to 0. And the complete solution is equal to the starting plus running. Starting plus running. It's just like in your second order control system. If you draw a graph for a second order control system, the complete response is initially it is having some starting transients and then it will steady it out. So this complete response can be divided into two categories. One is what a transient, another one is steady state. In the same way here also, the solution of state model is equal to the sum of zero input response plus zero state response. What is zero state response? Is L inverse of Si minus A into B into U of t. And from this particular one, Li minus A whole inverse is also known as phi of t, which is also represented in some textbook as e power at, and which is in terms it is known as what? State transition matrix. And mathematically, the complete time response for the state model is given by using this formula. By using this formula, and let me write here. Let me write here. So from that particular expression, we got x of t is equal to L inverse of Si minus A whole inverse into x of 0 plus same L inverse Si minus A whole inverse into B into U of S. L inverse of U of S. L inverse of U of S you got. So from this particular, this is x of 0. From this one, this is known as what? Zero input response. And this is known as what? Zero state response. Zero state response. So this is the thing. So this is the known as what? State model solution. Very simple solution of state model. And now next is from this particular expression I extracted two things. Remember point to be noted here. So number one is L inverse of Si minus A. Why I am stretching on this particular thing means, in some cases, rather than asking the x of t, he will ask directly only this one. Find out L inverse of Si minus A whole inverse, which is also known as phi of t in some textbook, which is also equal to e power at in some equation. It is also equal to state transition matrix. Why it is known as what? State transition matrix means this is the state where at initial condition, from this particular initial condition to the active state, it will go at this particular point x of 0. Hence the transition matrix which is multiplying with x of 0 is known as what? State transition matrix. So which is mathematical equal to L inverse of this one. And finally, the mathematical formula for x of t. The mathematical formula for x of t can be, the mathematical formula for x of t can be given by x of t is equal to e power at into x of 0, where e power at is once again this one, the same expression, plus integration of 0 to t e power a into t minus tau into b into u of tau. Remember, the integration is with respect to tau, not t. So the derivation is there for this particular formula to determine its time response. To determine the time response means solution. So this equation denotes the solution of state equation. And this equation is denotes what? A state transition matrix. These two. Let me write once again here. Under solution of state model matrix, I can write up the x of t is equal to 0 input response plus 0 state response, which is mathematically equal to simply short form go rastunna e power at. What is e power at? The L inverse of s minus a whole inverse into x of 0 plus integration of 0 to t e power a into t minus tau into d of tau. You need to remember this formula compulsory. And similarly, what is state transition matrix? Means it is mathematically equal to e power at, or which is also equal to phi of t, or which is also equal to L inverse of S I minus A whole inverse. So you need to remember these two formulas in this particular solution. So here is the end of this last but one concept in this particular unit. Now e topic pena once I completed the problems to solve, then here will be the end of last but one topic. So I will conclude these two concepts by solving the number of problems in this class and in the next class. With that, last but one concept will be completed. So next only one topic will be left over, that is controllability and observability. That we will discuss later on. So mathematically my job is over. Now we will solve before going for solving the problem. Here to solve the problem there is no procedure. Suppose he is asking you to find out state transition matrix, then he will be giving you the matrix of A matrix istadu. So A matrix ichna matrix ki Si minus A subtract chesi adjoint and determinant find out chesi L inverse apply cheyandi, you will get what e power at, which is known as state transition matrix. If he is asking to find out the time response x of t, then once again find out e power at multiply with x of 0, then substitute here also the same thing and apply integration and add with this particular one, then you will get x of t. So we will solve the problems in the next class. So meanwhile I'm having some time, so one problem I will try to show you here. So here let me solve this first problem. Now in this problem he has given you the equations and he has asked you to find out what a state transition matrix. What are the two equations he has given? X1 dot is equal to x2 and x2 dot is equal to minus 2x1 and minus 3x2. Let me write here. So he has given the x1 dot is equal to, he has given x1 dot is equal to x2 and x2 dot is equal to minus 2x1 minus 3x2. Now he is asking you to find out what the find state transition matrix. Find state transition matrix e power at. So solution for this particular problem is, so here the given data is, so convert those one into matrix form, then you will get x1 dot x2 dot will be equal to 2 by 2 matrix into x1 x2 plus bu plus b into u. Now if you observe here there is no input terms, hence the b matrix will be 0. And what about x1 dot? X1 dot is equal to x2. Now what is 0 1 and next minus 2 and then minus 3. So this is your A matrix and this is your B matrix. So what about e power A state transition matrix? Mathematically it is given by e power A is equal to L inverse of Si minus A whole inverse. So first of all you need to take Si minus A. So what you will get Si minus A? Si minus A you will get as S 0 0 S minus A is 0 1 minus 2 minus 3. So if you do the simple mathematics, you will get here as Si minus A as S minus 1 and then 2, and then S plus 3. S plus 3 is the thing. Now you need to find out the next step is Si minus A. So all of you are aware that Si minus A whole inverse is equal to M adjoint by determinant. Determinant. If you find the adjoint by determinant, what you will get the determinant? Determinant, if you find out multiply all those things, you will get a S square plus 3S plus 2, and in the matrix adjoint of that particular matrix you will get here as S plus 3, S plus 3, 1 minus 2, and then S, and then S. Now if you find out the roots of these two things, then you will get the roots are, then you will get the two roots are 1 divided by S plus 1 and S plus 2, S plus 2, and here S plus 3, 1 minus 2, S. So if you do simple mathematics on this particular one, then you will get the final matrix for this particular one is S plus 3 divided by S plus 1 into S plus 2, and once again 1 divided by S plus 1 and then S plus 2, and similarly minus 2 by S plus 1 into S plus 2, and similarly S divided by S plus 1 into S plus 2. Now if you observe here, now you need next step is to get the matrix, you need to apply inverse Laplace transformation. So to apply inverse Laplace transformation, this is not in the form of what? Direct application. So for this one, I need application of what? Application of partial fractions. Application of partial fractions. Application of partial fractions. If you apply partial fractions, then you will get here. You apply partial fractions and then apply Laplace transformation, then you will get a 2 e power t minus e power minus 2t, and here e power minus t and minus e power minus 2t, and similarly one more thing, minus 2 e power minus t plus 2 e power minus 2t, and then minus e power minus t plus 2 e power minus 2t is the state transition matrix, which is equal to e power at. E power at is the answer for that particular one. For that particular one. So it means that in some cases, rather than asking solution, simply he will ask you to find out the state transition matrix. So how to find out the state transition matrix means, for the given data, from the given data, you just subtract the A value with Si, subtract the A value with Si, and then find out the inverse of Si minus A. Then you will get what matrix. For that particular matrix, just simply apply inverse Laplace transformation. Apply inverse Laplace transformation. If it is not in a situation that you can apply inverse Laplace transformation, then before applying, apply partial fractions, convert into required form, and then finally apply the Laplace transformation. Means if you apply the Laplace partial fractions, then you will get these terms. If you apply, suppose if you apply partial fraction for this one, we apply partial fraction for this one, then that will become what? 1 by S plus 1 tarvata minus 1 by S plus 2. So all of you aware that formula for the applying the inverse Laplace transformation will be inverse of S plus A is equal to e power minus at. E power minus at. So by using this same thing, you can apply here. If you apply this one, then this will become e power minus t and minus e power minus 2t. The same thing what I have written here. So like this, rest of the things. Please make a note. Very simple problems here under simple application of matrices ఉంటే చాలు. Okay. So here is the end of my class. In the next class, we will solve number of problems on this particular topic, that is the determination of state solution of state equation. So one more problem. Meanwhile, as I have given the material also, you just do this second problem what I have given in your notes is second problem, and also do this two problems are there. One problem I have just solved. So this is the 3 by 3 order, the second problem, and then one more second order is this is the third problem. You please try to solve, refer the third problem. In the next class, directly I will try to go for this problem. That is the determination of time response for the given state model. One important question, this one. So we will try to solve this particular one. With that, this concept of solution of state model will be over. Then we will directly jump to the last concept. That is the concept of controllability and observability. The last concept of control system. So you please try to solve the at least one problem on state transition matrix. So overall conclusion of today's class is so today I concluded the state model representation in all the three cases. There is the first case is what circuit istadu, and the second case is he will give you the transfer function, and the third case is he will give you directly state model, and he will ask you to find out what transfer function. All the three cases we have discussed, and just now I derived the expression for how to determine derive the expression for how to determine the solution of state model, that is x of t. So simply two steps. One is apply Laplace transformation and then inverse Laplace transformation. Then we will get what x of t directly. So that x of t solution consists of two things. One is zero input response, another one is zero state response. Zero input and zero state response. The sum of these two. So overall, mathematically, the zero input response lo unna matrix ki also known as what? State transition matrix. Guna antam, and mathematically state transition matrix is L inverse of this one. So he will be giving you the value of A, and under the case of problem, he will be giving you the value of A, and he will ask you to find out state transition matrix. Appu em cheyalama, subtract A value with Si minus A, and then apply inverse Laplace transformation. Find the inverse of that particular matrix. After that one, apply inverse Laplace transformation. ఒకవేళ inverse Laplace transformation apply చేయనికి లేకుంటే use partial fractions application, and then apply inverse Laplace transformation to get the things in terms of time. That is known as what? State transition matrix. In the next class, we will go for how to find out x of t, which will conclude the last but one topic of your control system. So here is the end of my class.